I am Dr.G.B.Chandra Mouli, Assistant Professor of Mathematics, Freshman Engineering Department, Aditya University. Now we will see applications of first order differential equations. Under this we are going to see orthogonal trajectories. It is a continuation of orthogonal trajectories of Cartesian curves. Now at the end of this lecture, student will be able to find orthogonal trajectories of polar curves. In the previous lecture, we have seen orthogonal trajectories of Cartesian curves. Now we will see orthogonal trajectories of family of polar curves. So quickly we will see the definition of orthogonal trajectories once again. So a curve which cuts every member of a given family of curves at right angles is called an orthogonal trajectory of the given family of curves. So in the figure we see that the curve 1, which is represented here, which is given by the blue line, cuts every member of the other family of curves at right angles. So the family of curves are represented by these pink lines. So here you can see the angle between the blue curve and all the pink curves, family of curves, is 90 degrees. So here 1 is an orthogonal trajectory of the given family of curves. So the blue line represents the orthogonal trajectory and the pink lines represent the family of curves. Similarly, if you take family of curves, if every curve of a family 1 of curves cuts every member of another family 2 of curves at right angles, then 1 is said to be a family of orthogonal trajectories of 2 or vice versa. So here we have some straight lines given by family of curves 1 and 2 are circles, concentric circles. So here every straight line cuts every circle at right angles. So here if you take a straight line and see the angle between the straight line and the circles, okay, is 90 degrees. Similarly, another straight line cuts all the circles at 90 degrees. So here this family of straight lines are said to be orthogonal to this family of circles or vice versa. Now we will see the working rule to find orthogonal trajectories of polar curves. So working rule to find orthogonal trajectories in polar form or polar curves. Let f of r theta c is equal to 0 be the equation of given family of curves in polar form. So here r theta are the polar coordinates and c is an arbitrary constant for which this equation represents family of curves. Step 1. Differentiate equation 1 with respect to the independent variable theta and obtain the differential equation of the given family of curves as capital F of r comma theta dr by d theta is equal to 0 by eliminating the arbitrary constant or parameter c. So equation 2 represents the differential equation of the given family of polar curves. In step 2, again we have to replace the derivative. So here replace dr by d theta by minus r square d theta by dr in equation 2, and the differential equation of the family of orthogonal trajectories is given by capital F of r comma theta minus r square d theta by dr is equal to 0. So this equation 3 represents the differential equation of the orthogonal trajectories. Now in step 3 we have to solve this equation 3 and the solution will give you family of orthogonal trajectories of 1. Again to solve equation 3 we can use the methods like linear equations, exact differential equations or reducible to exact differential equations. Now we will see some examples based on this rule. Example 1. find the orthogonal trajectories of the family of cardioids which are given by r is equal to a into 1 minus cos theta, where a is the parameter. So, solution, given equation is taken as 1, r is equal to a into 1 minus cos theta, and we have to differentiate this equation 1 with respect to the independent variable theta, and we get dr by d theta is equal to a into derivative of 1 0 and minus derivative of cos theta is minus sin theta, that is equal to dr, that implies dr by d theta is equal to a into sin theta, or a is equal to 1 by sin theta dr by d theta. So, we substitute this a in equation 1 and we get r is equal to, this is a 1 by sin theta dr by d theta into 1 minus cos theta, or it can be written as dr by d theta is equal to r into sin theta divided by 1 minus cos theta. So, a is eliminated and this is differential equation of the given family of curves 1. Now, in this equation we replace the derivative dr by d theta by minus r square d theta by dr, and we get the differential equation of the orthogonal trajectories. So, on the left hand side we have dr by d theta which is replaced, and minus r square d theta by dr is equal to r into sin theta divided by 1 minus cos theta. So, cancelling r on both the sides. So, minus r d theta by dr is equal to sin theta divided by 1 minus cos theta. Now, we have to solve this equation and find the solution. Now, we apply a method which is called variables separable method. This is the basic method to find the solution of first order differential equations, and here the variables in the equation are separated and we integrate on both the sides to get the solution. Suppose we have the equation, if we can write the equation dy by dx is equal to f of x divided by g of y, then this can be written as g of y into dy is equal to f of x into dx. So, this differential equation is represented as g of y dy is equal to f of x dx, where on the left hand side we have all the y variable terms and on the right hand side we have all the x variable terms. So, x and y variables are separable here, and now this equation is said to be variables separable, and for the solution we have to integrate on both the sides. So, this is the basic method to solve first order differential equations. So, if we can separate the variables on both the sides in the equation, then that is said to be variable separable and its solution is obtained by integrating on both the sides. So, here the variables in this equation are r and theta. We see whether we can write all r terms on the left hand side and all theta terms on the right hand side, so that it will be variable separable. So, this can be written as 1 by r dr is equal to minus 1 minus cos theta divided by sin theta d theta. So, all r terms are on the left hand side and all theta terms are on the right hand side. So, this equation is variables separable. So, we can solve this equation by using this fundamental method. Now, 1 by r dr is equal to minus of, now divide each term by sin theta, 1 by sin theta minus cos theta by sin theta d theta. So, again 1 by r dr is equal to 1 by sin theta is cosecant theta minus cos theta by sin theta d theta, or multiplying the negative. So, we will get 1 by r dr is equal to cos theta by sin theta minus cosecant theta d theta. Now, this equation can be integrated. So, integrating on both sides we get derivative of integration of 1 by r dr as log r, and on the right hand side it is cos theta by sin theta, so whose integration will be log of sin theta, minus integration of cosecant theta is log of cosecant theta minus cot theta, plus constant of integration which is taken as log c, because all the terms are logarithm terms, the constant is also taken as log c. Now upon simplification, so log r minus log c, which is obtained from the right hand side, is equal to log sin theta minus log cosecant theta minus cot theta. Again, by the property of logarithms, log r minus log c is log of r by c, and on the right hand side also log of sin theta by cosecant theta minus cot theta. Now raising to the power of e, okay, on both the sides, we get r by c is equal to, log gets removed, r by c is equal to sin theta by cosecant theta minus cot theta. Now for simplification, for getting the similar form, we do some multiplication here. On the right hand side, we multiply and divide by cosecant theta plus cot theta. Now upon multiplication, on the right hand side we get sin theta into cosecant theta, which is 1, plus sin theta into cot theta will get cos theta, and in the denominator it will be cosecant theta minus cot theta into cosecant theta plus cot theta, which is cosecant square theta minus cot square theta, and this is equal to 1. So this will give you r is equal to c into 1 plus cos theta. So the original family of curves are r is equal to a into 1 minus cos theta, these are the coordinates. For this, the orthogonal trajectories are also written in the similar form as r is equal to c into 1 plus cos theta. So the required orthogonal trajectories are given by r is equal to c into 1 plus cos theta. Another example. So find the equation of system of orthogonal trajectories or the family of curves. This is r power n into sin n theta is equal to a power n. So these are the given family of curves, so where a is the parameter. Now the given equation is, this is also r to the power of n, r to the power of n sin n theta is equal to a to the power of n, and to eliminate a from this equation, we have to differentiate this equation with respect to theta. So here on the left hand side we apply for r power n into sin n theta, we apply product rule for this. First the derivative of r power n into r power n minus 1 dr by d theta, and sin n theta is fixed, plus this is r power n and into derivative of sin n theta, which is cos n theta into n is equal to 0. So now on both the sides, in all the terms we have r power n as common, so we can divide this by 1 by r power n, or we can divide by r power n, and upon cancelling that we get n into r power minus 1 dr by d theta sin n theta plus n into cos n theta is equal to 0. So in this equation we do not have the parameter a and it is eliminated, and this is the differential equation of the given family of curves 1. So the equation is r power n into sin n theta is equal to a power n, and it is differentiated with respect to theta, and obviously a is eliminated from this equation and the differential equation of the given family of curves is obtained. Now in this equation we have to replace the derivative dr by d theta by minus r square d theta by dr. Then we get the differential equation of the orthogonal trajectories. So n into r power minus 1 dr by d theta is changed to minus r square d theta by dr, and into sin n theta plus n into cos n theta is equal to 0. Now multiplying these terms here, so minus n into r d theta by dr sin n theta plus n into cos n theta is equal to 0. Now again this is solved, we have to solve this equation by using one of the methods where the easiest method to solve this will be the variables separable method. So, in the case of polar coordinates, in most of the cases, variable separable method will be easy to apply, where we can write the equation as f of r dr is equal to some g of theta d theta. That means we can write all r terms on the left hand side, r and dr terms on the left hand side, and all theta and d theta terms on the right hand side. So, we are able to separate the variables r and theta, so which means it is variable separable, and the solution is obtained by integrating on both the sides. So, here we will see, we can write this equation as n into r d theta by dr sin theta is equal to n into cos n theta. So, taking this term to the other side. Now, n into 1 by r dr is equal to n into sin n theta by cos n theta into d theta. So, all r terms are taken on the left hand side and all theta terms are written on the right hand side. So, this is variables separable. Now, we integrate on both the sides. So, before integrating, so again it is written as n into 1 by r dr is equal to minus of, so we are taking a negative sign, minus of minus n into sin n theta by cos n theta d theta. Now, we integrate this on both sides. So, we will get n constant into 1 by r dr integration is log r minus, so here the derivative of cos n theta is minus sin n theta into n. So, in order to get the derivative, we have taken the negative sign on the right hand side. So, now the integration will be minus log of denominator, which is cos n theta, plus a constant of integration which is taken as log c. Now, for simplification, we write this as log r power n, and by the property of logarithms it is log c divided by cos n theta, or removing logarithm, taking to the power of e on both the sides, we get r power n is equal to c by cos n theta, or r power n into cos n theta is equal to c. So, this final simplification is done in order to compare the form with the given equations. So, the given equations are r power n sin n theta is equal to c, and the orthogonal trajectories are also written in the similar form as r power n cos n theta is equal to constant. So, these are the required orthogonal trajectories of the given family of polar curves. Now, as a summary, we have seen the definition of orthogonal trajectories and how to find orthogonal trajectories of the polar curves and some examples. Thank you.